So yesterday we learned how to determine if a relation is a function. So today we're going to look at it in three different forms. We're going to look at it in a table, in a mapping, and on a graph to determine if something is a function. So for this first two examples, we're going to look at our tables. So in the first table we have 3, 2, 5, 4, 8, 7, and negative 1, 2. Those are our points. And so again, we want to make sure that x is not repeating. So if we look here, I've got a 3, I've got a 5, I've got an 8, and a negative 1. So since x does not repeat, then it is going to be a function. Again, it doesn't matter that there's a two 2's here because the y's can repeat, just the x's cannot. So yes, this is a function. Now if we look at example 2, we've got 3, 2, 5, 4, 3, 7, and negative 1, 9. Those are our points. What we're going to do is we have 3, 5, 3, and negative 1. So if we look here, the 3 repeats in the x. So no, this is not a function because of the 3 repeating. So we've got, because of these 2 points, 3, 2, and 3, 7. So since 3 has more than one y, it's not going to be a function. Our next examples here, these are called mappings. So we, again, have our domain and our range. So these arrows tell us what points they match with. So for example, negative 1 goes to 5. So we've got that point, negative 1, 5. 0 goes to 3. 1 goes to 5. 2 goes to 11. And 3 goes to 21. So again, we're going to look at our domain. We can't have the x's repeat. So if we look here, we've got negative 1, 0, 1, 2, and 3. So none of those repeat, so yes, it is a function. And without writing all the points, what you can look at too is in the domain to range in our mapping, each x only has one arrow coming off of it. So yes, 2 arrows go to 5, but each x only has one line coming off of it. So if we look at our second example here, we've got negative 2, 0, 1, 3 in our domain, and then negative 3, 1, 3, and 4. So if you look from negative 2 goes to 1, and it goes to 3. So that automatically tells us that we've got negative 2, 1, and negative 2, 3 as our points. So right there, we're going to have 2 of our x's that are the same. So for that reason, it's going to be not a function. And then lastly, we have on a graph. So when you have a graph, you use something that's called the vertical line test. So if you put a vertical line over the graph at any point, it will never hit 2 points on the graph. If it does, then it's not a function. So for the first example, we're going to take this red line. So this is a vertical line. And if I trace it over our graph here, it's never touching more than 1 point. So no matter what, it's always only hitting 1 point on the graph. So this is going to be a function. Then if we come down here to the circle, same concept. We're going to take a vertical line and we're going to trace it over the graph. So vertical line, and look, if we look right here, we'll go to 1. We'll go to 1, it hits the circle here and here. So this x equals 1 has 2 points. It's got a 3 and it's got a negative 3. So that graph has a point 1, 3 and 1, negative 3. So since the x repeats, we cannot have a function. So this would be not a function, and the reason would be because it does not pass the vertical line test. So go ahead on to the next page and you're going to do those next 3 examples on your own.